Let's take a look at example 1. Here they've given us the equation x squared minus y squared is equal to 16. They want me to find dy dx, and they want me to do so at the point -5, 3. So let's begin with our equation x squared minus y squared equals 16. There's no need for me to solve for this in terms of y because I'm going to differentiate this implicitly. So let's go ahead and take the derivative of both sides. So if I take the derivative of x, I'm going to take the derivative just like I normally would. I just applied the power rule to that. So y is not the only thing that gets differentiated. But when I take the derivative of x squared, I can also write dx dx. And what that means is the derivative of x with respect to x. Remember what we just said a moment ago. The numerator tells you what you're deriving, and the denominator tells you what you are respecting. So in this case, I was taking the derivative of x with respect to itself. Let me keep going. So this gives me minus 2y, and I'll write dy dx. And then this is going to be equal to, and if we differentiate a constant, we get 0. Now, let's go ahead and simplify this. dx is actually just 1, so we can write 2x minus 2y dy dx equals 0. A lot of people skip this step. They will just simply differentiate 2x and then go on and say minus 2y dy dx, because the dx is going to cancel. And it's fine if you want to skip that step, but it may help you to always write a differential when you take the derivative. And just think about what you're taking the derivative of and what you're taking the derivative respect to. And then if it goes to 1, it goes to 1, and if it doesn't, it doesn't. Feel free to skip this step if you want to. Okay, so let's go ahead and get dy dx on one side of the equation. So if we add the dy dx term to both sides, we get 2x is equal to 2y dy dx. Sorry. Now I can divide both sides by 2y. When we do this, the 2y's cancel, the 2's cancel, and dy dx is equal to x over y. And then I can write dy dx, and this may be new notation for you. Write a long vertical pipe, and at the bottom I'm going to put the point, -5, comma. And what that means is I'm going to evaluate the derivative dy dx at the point -5, comma 3. And so that is going to be equal to x, which is -5, over y, which is 3. And so my answer is -5/3.